This is for Year 12 methods and it covers transformations and looking at exercise 1.31e. State the transformations to achieve y equals 3 minus 2x all in brackets squared plus 1 from the original function y equals x squared. Okay, so I can see a number of transformations that are happening in here. The 3, the negative, the 2 and the 1 means 4 different transformations have happened. Because I'm interested in describing transformations as dilations, reflections, translations, DRT in that order, I need to do a little bit of isolation of the dilation, the reflection and the translation inside this bracket first. So I've got y equals, and I'm going to bring out the minus 2 outside of that bracket. If I take a common factor of minus 2 out of minus 2x, the x becomes positive. If I take a common factor of minus 2 out of the 3, I'm going to get minus 3 on 2. And then I'm going to have my plus 1. Now, the negative 2 and the minus 3 on 2 are all changes to do with x. This one over here are really changes to do with y. So I'm going to move that 1 to the other side, which gives me that expression. I can see one dilation. The dilation is the 2. X has been replaced with 2x. Therefore, that is a dilation by a factor of 1/2 from the y-axis. And that's my first transformation. X has also been replaced with negative. X replaced with negative x. Therefore a reflection over the y-axis. That's number 2. The last two are translations. X has been replaced with x minus 3 on 2, therefore a translation, right, 3 on 2 units. And y has been replaced with y minus 1, therefore a translation up 1 unit. So they are the 4 transformations that have occurred in that order. Another question in exercise 1.3 comes out of 7c. A quartic y equals x to the power of 4 is dilated by a factor of 1/2 from the y-axis, dilated by 1/2 from the y-axis, reflected about the y-axis, and translated to the right. If I have a dilation by a factor of 2 from the y, therefore replace x with x 2x. Reflection about the y, therefore replace x with minus x. And translation to right, therefore replace x with x minus 2 are my 3 replacements that I have to make. Okay, so piecing all of this together, I have y equals x to the power of 4. If I replace x with 2x, y equals 2x to the power of 4. If I now replace x with minus 1, I've got y equals minus 2x to the power of 4. And if I replace x with x minus 2, I've got y equals minus 2, x minus 2 to the power of 4. All I've done is replaced x with whatever x needs to be replaced with. And then that can be simplified to equal minus 2 times minus 2 is 4, minus 2 times x is minus 2x to the power of 4, and that's my new equation.